Hey everyone, welcome to the Simplilearn YouTube channel. Today we are here with an interesting video on the Minimax algorithm in AI. So without any further delay, let us have a look at the agenda for today's session. First, let us try to understand what is Minimax algorithm in AI. Then let us know the properties of the Minimax algorithm. And moving ahead, let us go through the pseudocode of the Minimax algorithm. And finally, let us understand its working. So, if you want to become an expert in the field of AI and machine learning, then take up the professional certificate program in AI and ML by Simplilearn and master those necessary skills. Check out the link in the description for more details. The Minimax algorithm is a popular decision-making algorithm in artificial intelligence used in game theory and decision theory. It is a backtracking algorithm that uses the depth-first search concept to traversal all the nodes of a tree, and it tries out different possibilities in a systematic manner and backtracks when a solution is not found. The Minimax algorithm is commonly used in two-player games like chess, checkers, and tic-tac-toe. The algorithm's main goal is to choose the best move for the player currently making a move, assuming that the opposing player would also play optimally, minimizing the player's maximum possible loss. Advancing, let's have a look at some of the properties of the Minimax algorithm. First, we have completeness. The Minimax algorithm will find a solution if it exists in the given finite game tree. Next, optimal. The algorithm is optimal if both players makes an optimal move. Then, time complexity. The time complexity of the Minimax algorithm is order of b to the power of m, as it performs a depth-first search of the game tree, where b is the game tree's branching factor and m is the tree's maximum depth. And then we have space complexity. The space complexity of the Minimax algorithm is the same as the depth-first search, order of b into m, as it follows the same principle. Next, we will move on to the pseudocode for the Minimax algorithm. Let's try to understand the pseudocode of the Minimax algorithm. So here, the function Minimax accepts three arguments, that is node, depth, and max player. So node, the current game state, and depth, the maximum depth of the search tree, and the max player, a boolean variable that indicates whether the current player is trying to maximize or minimize their score. So first, the function checks if the current node is terminal or if the maximum search depth has been reached. So if either condition is true, the function returns a heuristic node value. Next, suppose the current player is the max player. So in that case, the function initializes the best value to negative infinity. Recursively calling the minmax function, it evaluates each child of the current node with max value set to false. Here we have the max value that is set to false, and then the best value is updated as the maximum of the current best value and the value returned by the recursive call. And then finally, the function will return the best value. Else if the current player is the min player, the function initializes the best value to positive infinity, and by recursively calling the minimax function, evaluates each child of the current node with the max player set to true. So here we have the max player set to true, and the best value is updated as a minimum of the current best value and the value returned by the recursive call. And then finally, the function will return the best value. Next, let's move on to the working of the Minimax algorithm. Minimax refers to the algorithm strategy of minimizing the maximum possible loss. So, the Minimax algorithm works by constructing a tree of all possible moves and their outcomes starting from the current game state. A game tree is a graphical representation of the different moves that players in a game can make as well as the results of those moves. It is a game tree that starts at the root node and branches out into different nodes reflecting different possible moves. In game theory and artificial intelligence, game trees are often used to analyze and solve games. They can be used to determine the best move for a player given a specific game state or to compute the predicted outcome of a game depending on the each player's move. So let's consider this example where we have two players, max and min, and we also have the terminal nodes. So let's consider A to be the initial state of the game tree. So if max player takes the first move, then according to the pseudocode to the maximizer, it is the best value is equal to negative infinity. And for minimizer, it is the best value is equal to positive infinity. So we now find the utility value or score for the maximizer. The maximizer will compare each value of the terminal node with its initial value, which is negative infinity, and choose the maximum value among all. We have 4 and 2. So it will check the maximum value. So in 4 and 2, it will choose the value 4. And then in -3 and -6, the max player will choose -3 because -3 is the max value compared to -6. And then it will check in 7 and 0. So it will compare and it will choose the value 7. Then 5 and 8, it will choose 8. The next move is of minimizer. So it will start comparing all the nodes value with positive infinity. So basically, it will choose the values that are minimum. And it will choose the values or score for the third layer. So it will start comparing 4 and -3. So since -3 is the minimum value, it will choose the -3. And then in 7 and 8, it will choose 7 because it is a minimum. And then again the next turn is of maximizer. It will choose the maximum value from the node for the root node. So here in -3 and 7, the maximum is 7. So the maximizer will choose the maximum value to the root node. So this is the complete working of the Minimax 2-player game. So we have just considered 4-layer game tree, but when you take online 2-player games, they will have many layers in it. So just for our understanding, we have considered this example, but in online 2-player games, we will have complex game tree. And I hope you got the idea of Minimax algorithm. So guys, I have a simple question for you. So looking at this game tree, find out what is the optimal value and let me know in the comment section below. So if you like this video, share it with your friends. Before I sign off, make sure you subscribe to our channel and hit the bell icon to get all the updates. We'll be back with more such interesting videos. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.